In this video, we are going to talk about triple integrals with constant limits. The general form of a triple integral will be like this. There will be three integration and there is a function in terms of x, y and z followed by dx, dy, dz. The order may be different. Sometimes you may have dy, dz, dx, or sometimes you have dy, dx and dz and so on. So whatever may be the order, if the limits are constants, then we no need to worry about that. Sometimes the limits are like this: AB, here CD, and here we have EF. So all these values A, B, C, D, E, F, all these limits are constants. That means A, B, C, D, E, F, all these limit values are constants. So it depends on the order of integration, we can perform our integration. Say for example, if I have the order like this: dx, dy, dz, then I have to integrate the given function first time with respect to x, second time with respect to y, and third time with respect to z. Similarly, if my order is like this: dz, dy, and dx, then I have to perform the integration first time with respect to z, second time with respect to y, and third time with respect to x. Let us see some examples on triple integrals. Example number 1, we have given integral 0 to 2, integral 1 to 3, integral 1 to 2, and this is my function x y to the power 2 z dz dy dx. So here the order of integration is dz dy and dx. Here the limit of z equal to 1 and 2. Lower limit is 1, upper limit is 2. The limit of y equal to 1 and 3. Lower limit is 1, upper limit is 3. And the limit of the variable x is 0 and 2. That is, lower limit is 0, upper limit is 2. So first I have to integrate the given function. What is my given function? My given function is x y to the power 2 z. So we have to keep the two integrals as it is, that is 0 to 2, 1 to 3, 1 to 2, and this is my function, right, followed by dz, dy and dx. So what I have to do, first I have to integrate with respect to z, then second time I have to integrate with respect to y, and third time I have to integrate with respect to x. So let us begin the problem. So what I have to do, I have to keep the outer integrals 0 to 2 and 1 to 3 as it is. Take the function is x y to the power 2 z. I am going to perform the integration with respect to z first. So that means x and y power 2 I am treating as a constant terms. Integration of z will be z squared by 2. Then I have to substitute the limit for z. The limit for z are 1 and 2. Now 0 to 2, integral 1 to 3. So wherever you have z, you have to replace z by the upper value 2. So that means I have to keep x y power 2. In place of z, let me substitute the upper limit 2. We have z power 2. Z power 2 means 2 power 2. 2 power 2 is 4. 4 divided by 2 will give you 2. So I have 2. Before substitute lower limit, I have to put a minus sign. Then replace z by 1. So z power 2 means 1 power 2. 1 power 2 is 1. So this is 1 divided by 2. Still we have dy and dx. The value of 2 minus 1 by 2 will be 3 by 2. So let me take 3 by 2 outside. The remaining terms are 0 to 2, 1 to 3, x y power 2 followed by dy and dx. Now what I have to do? Now I have to integrate this function with respect to dy. So we can keep 3 by 2 as it is, and I am keeping the outer limit 0 to 2 as it is. Integrate x y power 2 with respect to y. That means I keep x as a constant term. Integration of y power 2 with respect to y will give you y power 3 by 3, and I have to replace the limit as 1 and 3. Still we have dx. So this will become 3 by 2 integral 0 to 2. I need to replace the value of y with upper limit and lower limit. My upper limit is 3. So 3 to the power 3 will be 27. 27 by 3 will give you 9. So we have 9x. Before substitute lower limit 1, we have to put a minus sign. Then I will replace y value by 1. So we have 1 power 3, which is 1. 1 multiplied x will be x. So we have x over 3. So this is the remaining function. This I have to integrate with respect to x. So let me keep that 3 by 2 as it is. Integration of 9x with respect to x will give you 9x power 2 divided by 2 minus integration of x will be x power 2 by 2. In the denominator I have a 3. So we have x squared over 6 between 0 and 2. Now substitute upper limit 2 and lower limit 0. That will give you 3 by 2, 9. First I have to replace x value by 2. So this will be 2 power 2. 2 power 2 is 4. 4 divided by 2 is 2. So 2 multiply 9 will give you 18. So this is my upper limit. Minus we have another x also. Okay, so in this term also let me substitute 2. So this will be 2 power 2. 2 power 2 is 4. So 4 over 6 will give you 2 by 3. So these two values for upper limit. Okay, then let me write minus sign, substitute lower limit. Here the lower limit is 0. So when I substitute lower limit, I will get only 0. By simplifying this, we will get 3 by 2, 52 upon 3. So the final answer will be 26. Let us discuss question number 2. Question number 2 is integral minus 3 to 3, 0 to 1, 1 to 2, x plus y plus z, and the order of the integration will be dx, dy, and dz. That means first time with respect to x, second time with respect to y, third time with respect to z. So let me keep the outer integral minus 3 to 3 and 0 to 1 as it is. Take the function. In the function we have x plus y plus z. Integration of x with respect to x will be x squared by 2 plus integration of y with respect to x will be yx plus integration of z with respect to x will be zx, and then I have to keep the remaining derivatives dy dz as it is between the limits 1 and 2. Then I have to substitute the upper limit 1 2, lower limit 1 in place of x. So we will get this one. This is for upper limit minus, and this is for lower limit. Now let me distribute this minus sign. So this will be minus 1 by 2. This will become minus y, and this will become minus z. If I simplify this, I will get integral minus 3 to 3, 0 to 1, 2 and minus 1 by 2. So this will become 3 by 2 plus 2y minus y. This will become plus y. Similarly, 2z minus z, this will be plus z. So still we have dy dz. So now let me keep the outside integral minus 3 to 3 as it is. Integration of 3 by 2 with respect to y will be 3 by 2y plus integration of y will be y squared by 2. Integration of z with respect to y will be zy between 0 to 1 dy dz. So we have minus 3 to 3. By simplifying this, we are getting 2 plus z into dz after substituting upper limit and lower limit. Now let me integrate this function with respect to z. This will give you 2z plus z squared by 2 between the limits minus 3 to 3. By substituting upper limit and lower limit, we will get this one. Cancelling minus 9 by 2 plus 9 by 2, we have left with 6 plus 6. So the final answer is 12. Now let us discuss some problems in the concept of triple integrals with variable limits. given integral 0 to 1, integral 0 to 1, integral 0 to y, and I have the function x, y, z. The order of the integration is dx, dy, dz. So as usual, let us keep the outside integration as it is. Integrate this function with respect to x. So we have x squared yz divided by 2. And I have to replace upper limit as y, lower limit as 0, then dy dz. So this will become 0 to 1, 0 to 1. If I substitute x equal to y, I will get y power 3 z divided by 2. When I substitute 0, this will become 0. So we have only y power 3 z by 2. Next step, keep outside integration 0 to 1 as it is. Integrate this function with respect to y. So integration of y power 3 will be y power 4 divided by 4. In the denominator we have 2. So this will become y to the power 4 z divided by 8 between 0 to 1 and dz. By substituting upper limit 1, this will become z over 8 into dz. By integrating this function with respect to z, we will get z squared by 16. Substitute upper limit 1, this will become 1 by 16. Substitute lower limit 0, this will be 0. So the final answer is 1 over 16. Question number 2. Here we have given integral 0 to 1, integral y power 2 to 1, integral 0 to 1 minus x, x into dz dx dy. That is first time with respect to z, second time with respect to x, third time with respect to y. As usual, first we have to keep the outside integration 0 to 1 and y squared to 1 as it is. Integration of the function x with respect to x z will give you x z between the limits 0 to 1 minus x dx and dy. So this will be 0 to 1 y squared by 1. By substituting z equal to 1 minus x, we have x minus x power 2 and dx dy. Again keep 0 to 1 as it is. Integrate this function with respect to x. So this will give you x squared by 2 minus x cubed by 3 between y power 2 to 1 into dy. So this will become 0 to 1. By substituting the upper limit 1, this will be 1 by 2 minus 1 by 3. Then minus of substituting x equal to y squared by 2, sorry, y power 2. This will be y power 4 by 2 minus y power 6 by 3 into dy. By simplifying the expression, we will get this one. Then integrate every term with respect to y. You will get this one. Substituting the limits 0 and 1, I will get this one. By simplifying this whole, we will get the final answer as 4 over 35. So these are the exercise problems with solution. Try yourself. See you in the next video.